So on the back, we are doing the inverses. All right, so we are going to take the inverses. We're going to do it algebraically. So on that poster over there, all about the inverse functions, we're doing the algebraically part. All right, we're not going to do the other stuff, algebra. So for solving these algebraically, you interchange x and y, and then solve for y. Those are the steps. Interchange x and y, solve for y. We have done this before, just not with exponentials and logs, so it should sound familiar. So part D, we have all these exponential functions. I want to find the inverse. So first I'm going to switch the x and the y. So that's going to become an x, and that's going to become a y. Okay, now I need to solve for y. On the front, I don't know if you remember, I always liked having the exponent on the left side. All right, like here I had to switch stuff around. So when you're solving, I still like having the exponent on the left side. So I'm just going to move this equals x over here. And then that way my exponent's over here on the left. Does that make sense? All right, so I just push the equals x over. Now I'm trying to solve for y. Looking over here on the side with the y, is there anything you can do to get rid of a number?
You add 2.
Add 2, so let's do that. So we're going to add 2. So 4 to the y equals x plus 2. Okay, now for, we add, we subtract, we multiply, we divide, we do all that good stuff, but nothing will get rid of this 4. Because it has an exponent of a y, and that's really strange, right? There's nothing you can do to get the y that we know of yet, which is where the logs come in. So the log operation will get that y out of the exponent. So once you get to this step and you're like, oh, what do I do next? You turn it to a log. So first we're going to write the word log, so we're putting it in log form. So the very, very left number, 4. So log base 4. And then we're going to go all the way to the right. Well, all of this stuff is on the right. So we're going to say log base 4 of x plus 2. All of it, because it's all on the right side. And then equals y. And now is y by itself? Yes. So that's your answer.
You can plug that into the, you can plug both of those into the calculator, right?
Yes, and they should reflect over the line y equals x. All right, jump to number 18. I'm kind of jumping around a little bit. Thank you, Alize. All right, we're switching the x and the y. So that becomes an x. This becomes a y. And then I don't like the equals x over there, so I'm going to put it right here. And so very good, we're going to minus this 3.
Oh, number 18. Whoops.
Yes, I'm sorry, I'm skipping around. All right, so I minus the 3. Over here with the y, there's nothing I can do, so I'm going to put it in log form. So log base what? 5 of x minus 3. Make sure you put it in parentheses because it's all of x minus 3. And then equals y. All right, jump up to number 15. All right, on number 15, we're going to start off the same way. The y is going to turn into an x. The x is going to turn into a y. And yes, this plus 1 is an exponent, so make sure it's all tiny. And then I don't like the x over here, so I'm going to put equals x right there. All right, can you get rid of that 1?
Yes, it's infernal.
No, I don't think you can.
Oh,
No.
wait, no, it's up top. Sorry.
Right, no, because it's an exponent. So you can't get rid of the 1, it's an exponent. So we are going to put it in log form because there's nothing I can do over here. So we're going to say log base what? 5 of x equals
Y plus 1.
y plus 1. Is y by itself? No. But what do I do to get it by itself?
You can subtract 1.
Now I can subtract the 1. Now you cannot combine anything. This log of x, that's all one term. So it's not in parentheses. We're just going to stick it on the outside. Because we're not going to take the log of -1. So the -1 is going to go on the outside. It's like your up and down shift.
Oh,
So then
okay.
why don't you put it in parentheses? Like, why can't you put the x, like the log of x in parentheses and it's like,
Oh, you can put this in parentheses like that. Is that what
I'm
you...
trying to put the whole thing like from log to the end of x.
Oh, like this.
yeah,
That's fine.
okay.
Yeah, you don't have to, but you can if you want. Okay. Jump over to, let's do 19. So 19 is going to be, I guess, the most involved. It has the most numbers that you're going to see. Same steps, though. So we're still going to switch the x and the y. That becomes an x. That becomes a y. And I don't like my x over here, so I'm going to put equals x right here. So I'm trying to get y by itself. So can I do anything over on this side to help me?
You can
Add
add 8.
8. Add 8. I have 9. Y plus 4 equals x plus 8. Okay. There's nothing else I can do over here but the y, the plus 4, that's in the exponent, so you can't mess with it. So we're going to go around the world, put it in log form. So log, base what?
9.
9 of
X plus 8.
x plus 8 equals
Y plus 4.
y plus 4. And now the x plus 8 is in parentheses because we're doing log of all of that. And then what's the very last step?
Subtract 4.
Subtract 4, which will get stuck on the outside. So log base 9 of x plus 8 minus 4 equals y.
And you can't combine it.
No, you can't combine the 8 and the negative 4. Alright, so how are we doing on inverses? Pretty good? Pretty good, pretty good. I told you this is the hardest part for this week, right? No? Yes. It's the hardest part for this week.
Oh, I like it.
Sweet. Hopefully the rest of this week is going to be just as easy.
Do we have a party?
Maybe next week. During review week, you know. We'll see. Alright, finding the inverse of logs. So we're doing the same exact thing, except now I have a log function, and I'm going to inverse it into an exponential. Alright, same steps though. Switch the x and the y. So this is going to become an x. This is going to become a y. I like to have my log on the left side, so I'm going to move this equals x over. Just like I did before. So remember, you're trying to solve for y. So can you do anything to this side to help us get y by itself?
You can subtract 5.
Subtract the 5. So minus 5. Minus 5. Log base 2 of y equals x minus 5. Alright, so there's nothing I can do with the log base 2 to help me get y by itself, so I'm going to put it in the other form. Now this is log form, so now I'm going to write it in exponential form. So the very, very left number is
2.
2. All the way to the right is going to be
X minus 5.
x minus 5, and so that whole thing will be your exponent, and then equals y, which is all by itself, so now you're done. That makes sense? Alright, hop over to number 21. Just 2 more. I'm just going to do 2 more. We're going to skip the other ones. Alright, this becomes an x. This becomes a y. And I'm going to move the x equals over to the other side. Now, can you add 1? Can you get rid of this 1 by adding it? No, it's in parentheses with the log, so you can't mess with it. So we're going to put it in the other form. So the very, very left number is
3
raised to the x equals
2y minus 1.
2y minus 1. All right, and so now I can get y by itself by adding 1. Now you cannot add the 3 and the 1 because the 3 has that exponent. So we're just going to write 3 to the x plus 1 equals 2y, and then divide by 2. And so just divide everything by 2, and then that is your answer. 3 to the x plus 1 over 2 equals y. All right, last one, number 22. So just like before on the other section, this is when you're going to have all the numbers. It's going to be the most involved, but still not that bad. Switch the x and the y. So x equals log base 5 of y plus 3 minus 2. Move the x equals to the other side. Very good. And then we're going to add 2. Add 2, add 2, log, base 5, y plus 3, equals x plus 2, very good. All right, now, you can't get rid of the 3 because it's in there with the log, so we're going to go around the world. And when you go around the world, you get what?
5
5
raised to x plus 2
raised to the x plus 2.
equals y plus 3
And then the very last step,
minus 3
minus the 3
so 5 raised to x plus 2 minus 3 equals 1.
equals y.
I heard my brain doing that.